Welcome to Math Chat, the call-in show that answers all your questions. I'm Frank Morgan, professor of mathematics at Williams College, and I have here with me tonight last week's prize winner, Curry Sullivan, who has stopped by to pick up her prize, and I think you'll be pleased with it, Curry. Welcome.
Thanks.
Nice to have you here, and I see also in the studio here we have your mom and your sister Kim are with us tonight, so that's nice of them to be here. Now your dad won our standard prize a couple of weeks ago, this Flatland, which teaches how to understand the fourth dimension. One of the most popular books, math books around. But you know, Curry, I consider there to be a sequel to this math book, Flatland, which has come out more recently. And that is this book called The Boy Who Reversed Himself by William Slater, which explains not only the fourth dimension in greater detail, but also the fifth, sixth, seventh, and higher dimensions, how to understand them. It's an adventure story, and the star of the story, the heroine, is a girl who reminds me very much of you, Curry. So this is your prize. Congratulations.
Thank you.
I think maybe it's inscribed there, is it?
Mm-hmm.
What does that say?
To Carrie, Math Chat Prize. Congratulations and thanks for being on the show. Frank Morgan.
Very good, and it is great to have you on the show this week. Have you had a good week? Anything happen to you this week?
We had the math fair at Pine Cobble.
The Pine Cobble Math Fair. Now I know about that. That is a great event. Now did you do a project for that?
Yeah, I did a project about proportion in art, music, and the human body.
Proportion in art, and I think maybe we have that poster here. Maybe we can see that in front of the cameras here in a moment here. Proportion in math, art, and the human body. So what proportions did you look for, or what did you measure there?
Well, I learned about the golden proportion. The
golden proportion. This is supposed to be the ideal proportion between length and width. And how big is it about?
It's an inch. It's 1.6.
About 1.6. So an ideal scale, for example, and your head looks about like that. You notice her head's about 1.6 times its width, and that's what helps to make you so beautiful, I think, that golden ratio proportion. Right, that's very interesting. And you know, actually, if we're only taking calls now, ladies and gentlemen, that refer to the Pine Cobble Math Fair and to Curry, but it was really a great event, and I was going to challenge the audience to see what they know about measurement and proportion. You know, one measurement we use is the foot, of course, which is related to the human body. Most measurements have nothing to do with the body, the yard, the mile, the inch, and so on. But I wanted to challenge the audience to come up with two other units of measurement in the English that we use, maybe not so frequently anymore, but that have existed, which are based on the human body. So measurement units based on the human body. Take calls on that, or maybe any comments on that math fair. I thought it was a terrific thing. Actually, I was also interested in that exhibit by Adam Rothschild. Did you see that? He did some math magic. It was really a good show. And also there was Mark Edwards, who had an exhibit on the calendar. Now, you remember we talked about leap years here on the show last week. He was interested in that, called me up during the week. We had a nice talk, and he had a really very interesting exhibit on the calendar. Now that we've switched from the Julian to the Gregorian calendar, which ought to last us a good 10,000 years before we need to fix it up.
Wow.
So it was a great event, though, wasn't it?
Yeah.
Yeah, right. Is there anything else anything else you've been up to, or you'd like to say? Why don't you just say goodbye to the audience here, and I want to thank you very much for coming by and being on Math Chat this week, Carrie.
Thanks.
So thanks for coming.
Bye.
Thanks for coming. Great to have you here. Right, so the inch actually, you know, was not based on the body at all. The inch originally came from the size of 3 barley corns. 3 barley corns.
What are barley corns? That's what I want to know.
So I've got my co-host back here. Aaron Dupuis is here, and we also have
Liz Claflin on camera.
Good, and Charmaine Mangrum upstairs on the mixer. And actually, I think a friend of hers, Maggie Adler, is helping out upstairs tonight too. And on phone,
Eric Watson.
Eric Watson on phone. So we have a lot of things in store tonight and things coming up this week. Tomorrow is the Williams College Monthly Math Dinner. And as a prize this week, we're going to offer invitations to the math dinner. There will be some alternatives if you can't make it, but that's fun to come. Or if you don't win an invitation, special invitation, anyone in our audience is welcome to come and buy a ticket for $5. That's going to be Monday, 5:30, Dodd Dining Hall on campus.
Is the food going to be any good?
Well, it's Williams College Dining Hall food, Aaron.
Well, yeah, that's what I'm asking.
I think
we have a call now.
It's really, well...
You're on the air, go ahead.
Yes, is the cubit the unit of measurement based on the human body?
The cubit, that's right. And what is the cubit? Is another measurement based on the human body. And what is the cubit?
Is that from your elbow to your finger?
Elbow to the tip of your finger. So you got one there. The cubit, that's right. So it's generally called about 18 inches. That's excellent. Your name is?
My name is Burton.
Burton. Okay, Burton. Well, that's excellent. Any others?
I don't know.
Okay, so Burton gave us one there. We're still looking for one other, but we'll have a prize for you if you call in with your address at the end of the show, Burton, and leave it on the answering machine for us.
Okay, thank you very much.
Okay, very good. The
Bye-bye.
cubit is actually a very interesting measurement. But I wanted to mention some of the other, before we even take a next call, I wanted to mention some of the other events that are coming up this week. There are some of these, the undergraduate colloquia this week are being given by A.J. Burnheim and Crystal Williams on Monday and Wednesday at 1 o'clock.
Crystal Williams is giving a
You
call?
know Crystal, right? Don't
I
you
do
think
know
that'll
Crystal.
be fun? So that's Wednesday at 1. I think these will both be fun this week. And on campus Tuesday at 8, there's going to be this violin prodigy giving a concert, Layla Yosefowitz. Brooks Rogers at 8 on Wednesday, so I think that'll be a great thing. And
I think we have another call now.
Before, I just wanted to say one thing about the calls there. We'll pick that up in a minute. We're pleased to say, the audience, we now have caller ID. So we're pleased to be able to manage our show with that from now on. And we're also asking for callers, we're just asking for your first name when you call. Please use your own first name. And all right, Aaron,
Okay,
we got
we have
another
a call
there. You can take that, I think.
Okay, you're on the air, go ahead.
Yeah, I have more units of measurement based on the human body.
All right, is this Tyler?
No, this is Nico.
Oh,
Nico, okay.
Nico, right. I knew I recognized that name, that voice there. Okay, Nico, we're ready for another one.
Okay, they're hands you use to measure horses.
You knew that. Yeah, use a hand. You know how big that is?
No clue.
About 4 inches, just to measure the height of horses. That's right. Very good, excellent.
And then you use fingers to measure amounts of alcohol, supposedly.
I didn't know that. You mean the thickness of a finger or something?
I don't know.
How would you use a finger? We're going to have to learn more about that. Finger to somehow measure amount of alcohol or something. I didn't know about that, Nikos. That's an interesting one.
That is interesting.
That's an
Professor
interesting one. And Nico, I think this brings you up to what, 4 of your 5 points you need for winning my calculus light book. Is that right?
I guess so.
I think that's where we are. So one more successful call in, and you're going to have my calculus book coming your way to you and your family.
Good.
Then you'll be the first ones to amass that 5-point total to do that. Of course, Aaron has that book already.
I do have that book.
He's slaved away over that a bit.
I have a
and
little.
he's continuing on into
Math 104.
that second semester calculus,
Yes.
integral calculus. And you're going to be a good calculus student, I think, Nico. You know anything about calculus?
No, I'm doing geometry now.
Well, geometry, you know, has some aspects of calculus in it. To figure out areas, unless you have special tricks,
You have to take the integral.
you have to use the integral, which you'll learn about in calculus. Otherwise, you can only do areas of rectangles and triangles.
Maybe circles.
Well, even for circles, you really have to use the idea of integration. That's how the Greeks came up with the area of a circle, by cutting it up into infinitely many skinny triangles.
But now we have the formula, so we don't need calculus.
Well, calculus is how you get the formulas. That's right.
But now that we have it.
Oh,
Oh, I see. Yeah, Nico, you're going to save me from my
my
co-host
father
here?
asked how you calculate pi.
And now we have a question about how you calculate
Is it-
pi, because that comes in this formula.
Pi is the
see?
ratio to, it's the circumference versus the diameter, isn't it?
That's right. So it's the ratio of the circumference to the diameter of a circle. And one way you could measure pi is to just draw a circle, measure the circumference, measure the diameter,
And then
divide. What you get is pi. Of course, you got to do this carefully. Back in biblical times, they thought it was about 3. Or later, people thought maybe it was a little bigger. Right now, we have it to much higher accuracy, and it can be computed using formulas from calculus. You bet. And I don't know, we could say more in detail about where those come from.
Okay, Nico?
Okay.
All right,
You
thanks a lot.
satisfied?
Thank you. Bye.
Thanks, Nico. Yeah, kind of interesting, huh? So we got the hand here, and the finger, and the cubit we have so far, the cubit. But you know, we were talking about, back to some biblical references, one of the famous ones is to the height of Goliath. He was 6 cubits and
Hand.
no, it's another word. We'll see if anyone in the audience can come up with that and then help us figure out how tall Goliath was in these old units. But remember, the 6 cubits, that's already big. 6 times 18 inches.
Pretty tall.
This
And we
is
have another
already
call.
merging on 9 feet.
Live on the air, go ahead.
Yes, I'd just like to ask about the math dinner. It's Monday night.
The math
It
dinner.
is Monday night.
How do we get invited to that?
So there are 2 ways to get invited. You can get a free invitation by answering one of our questions and winning a prize here.
Are you going to ask these questions on the show?
For example, right now, if you could tell us another unit of measurement that's based on the human body, we would offer you a math dinner invitation.
The hand or the cubit?
The hand and the cubit we have already got, or they would be winners. That's
I
that's
just heard you saying before. I thought you were trying to...
no, we need some new ones here. We need some new ones. Or, if you like, you can come and buy a ticket at the dinner for $5.
Oh, really?
Yeah. Okay, so thanks
Okay.
very much
Thank
for
you.
calling.
All right, thank you.
So, ladies and gentlemen, that's right. That's another prize you can opt for. And Burton also, who already won a prize tonight, if you'd rather have the math dinner prize, you can tell us that, leave that answer on the message machine, and show up on Monday evening at 5:30. You know the length of the foot changed in 1959?
Why? Because there was a new king, I bet.
No, this was 1959.
I heard that they measured the length of the king's foot, and that was what the foot
That
would be.
was a foot back in the earliest days. It was really the length of the king's foot, and so from reign to reign it might change. Also, each king wanted to claim to be bigger than the earlier king, so would often report an even larger foot. So it was getting pretty long, and 12 inches is pretty long now, you know. I bet you don't find many people whose feet are really 12 inches long.
No. Oh, we have another call? Live on the air, go ahead.
Yeah, I have an integral problem.
Oh, good, an integral problem. Who's calling?
Mark.
Mark, okay, welcome. And you're a college student?
Yeah.
Okay, Mark, go ahead.
Can you solve the integral of square root of 4x squared minus 1?
The integral of 4x squared minus 1 dx. The integral
Over x to the 4th, dx.
So we have the square root of 4x squared minus 1, right?
Yeah.
And then all that over x to the 4th,
Yeah.
and then times dx.
Yeah, and substitution.
And substitution, yes. So do you want to recommend a substitution here, Aaron? So these are problems that come up in calculus, might have to do with figuring out area. And listeners who don't know calculus, you get a chance now to just sort of eavesdrop on what a calculus question might sound like. So try to pick up some of these words.
Let me see. Substitution.
So you see that
U
square
equal.
root.
Was it the square root of 4x
We're going to let
minus
x.
1?
Yeah, we're going to let x equal something there, Aaron. See, we've got this square root of 4x squared minus 1. So we wish that that would come out nicely, and so we want to put in something so that when you square it and subtract 1, you can simplify it. Now, do you know of any trig identity like that?
I don't remember my trig identities.
Secant squared minus 1 is tangent. That's one thing you could try. And also hyperbolic cosine minus 1 is hyperbolic sine squared. So what you would want to do is you would want to let 4x squared be either cosh squared or secant squared.
Okay.
You make that substitution, then the numerator will turn into a sinh squared or a tangent squared. The denominator will be some trig or hyperbolic trig function. And then you have a new problem, which is a little easier. So I think that's as far as we'll go with that one, Mark, but there's a start for you.
All right.
Okay?
Thank you.
So
Bye-bye.
tell us a good luck on that, yeah. So, you know, it just goes to show, though, that to do what the Greeks were trying to do and to use calculus, you have to know some trig, too. And so, audience folks, when you get a chance to learn a little trig, learn about not only sine and cosine, but tangent and secant, and later on the hyperbolic trig functions, the so-called sinh, hyperbolic sine, and cosh, hyperbolic cosine. These are things that are very useful in figuring out areas and going beyond anything that the Greeks could do back in their time. So why did the length of the foot change? Remember, we got that, and I don't think
I don't know. I took my shot. I took my stab at it.
Well, you see, it was just how to relate the foot to the metric system.
Okay.
When the metric system was starting out, there was some formula for the meter in terms of the inch. It was 39.37 inches. But later on, when the meter became more important, they wanted to turn it around and define the inch in terms of the meter or centimeter. Well, the inch was 2.540, blah, 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 blah. Lots of decimal places, too complicated. So they decided to shorten the inch to exactly 2.54 centimeters. And this had the effect of shortening the foot and shortening the mile, but it wasn't by too much. You know by how much the whole mile was shortened?
By a foot.
By 3 millimeters. You can hardly see it, 3 millimeters. Just about a couple parts in a million.
Okay,
So
I
you
think we
wouldn't
have
even
another call
notice
now.
it, but it was just the tiniest little change.
Live on the air, go ahead.
Millimeters in the whole mile.
Go ahead.
Hello.
Yes. What's your name?
My name is Matt.
Okay. Go ahead,
Matt,
Matt.
we've had you before, I think?
I don't believe you have.
Oh, well, welcome to MathChat.
Thank you very much. My measurement is the rule of thumb.
The rule of thumb, and how does that go? What's the rule of thumb?
I believe this dates back to colonial times where you were allowed to beat your wife with a stick no larger than your thumb.
Is that true?
I don't know.
Or are you
it's an old
making this
legend. I
up?
don't believe in it. I kind of disagree with it.
Some
But,
people, no, wait, we see our camera person here, Liz Claflin, says that that's right. And she's conveying information from upstairs. So,
and you know
so
what?
this is where the expression rule of thumb came from, huh?
Yes.
A rule of thumb is something that had to be, so this
beat
gave
your
a
wife
guideline.
with a stick?
Well, fortunately, we don't use that
Interesting.
rule of thumb anymore. But
Right.
we have other little guidelines that tell you when you can do something or not. All right, Matt. Well, Matt, would you like the dinner invitation, or would you like Flatland as your prize?
I'm sorry, what was Flatland?
Flatland is a wonderful book that helps you understand the fourth dimension.
I would love the book.
Okay,
I
so
really would.
you call in to the answering machine right after this show's end and leave
Okay.
your address, and we'll make sure you get a copy.
Thank you very much.
Okay,
Thank you.
Thanks for calling.
Good
in.
night.
Bye-bye.
That's interesting. That's a pretty big
That's
stick.
where rule of thumb. Now that was dangerous. I think
Yeah.
that was a bad rule of thumb. Imagine beating someone. Beating someone with something this is about an inch thick here. I think this ruler.
Hey,
And you
hey,
can
watch
imagine,
yourself.
Oh, right. You can imagine that. I think is a little too thick, but that's rule of thumb.
Well, I don't think you should beat anybody with any size stick.
I think that's a good rule of thumb.
Unless they
Aaron.
deserve it, of course.
Good. No, I don't think we'll have any beating at all. Good rule of thumb there. So a mile turned out to be just about
I think we have
that
another call.
little bit longer.
Live on the
I don't
air,
get a
go
chance
ahead.
to talk about that, do I?
Hi,
Yes.
my name is Mary,
Okay.
Mary,
and I'm calling to answer the question about the finger of liquor.
Okay.
Oh, really? Good.
And I looked it up in the dictionary, and it says a measure varying from 3/4 of an inch to 1 inch, a portion of liquor filling a glass to such a measure of depth.
I see. So it measures how deep the liquor is in the glass, and since it's 3/4 of an inch to an inch, what is that? That's supposed to be the thickness of a finger, do you think?
Well, it
I
goes
think
on to
so.
say
That's pretty close.
It's also the length of a finger, a measure in domestic use in the U.S. of about 4.5 inches or 1/8 of a yard.
So you could use the thickness of a finger to measure alcohol, or
Right.
you could use the length of a finger.
Yeah, short fingers.
My finger isn't long enough here. Aaron, can you do better here?
Sure, I can.
Yeah, your finger is 4.5 inches.
I do my best.
You have a standard finger there.
Thank
I
you
have
very
a short
much.
finger,
Thank
don't
you very
I?
much.
Well, that's very interesting, Mary. We want to send you a prize for that. Would you like to come to our math dinner, or would you like Flatland?
I'd like Flatland.
Okay,
Everybody wants Flatland.
Well,
Nobody wants to eat the Williams
Flats-
College dining services food.
Well, I'm sure these people are probably just busy.
They don't know
you
how good it is, I think.
And the company, you know, at these math dinners, you get to meet people from our math department, other students and faculty. You don't know who might be there. So you could have a lot of fun at these math dinners. But we'll make sure you get this book, Mary, if you leave your address after the show
I will, thank you.
on our telephone
Thanks for the call,
number.
Mary.
Oh, you're
That'd be
welcome.
great.
Bye-bye.
How about that? Finger use both for the width and the length.
So
I
what do we
didn't
have
know
now? We
that.
have the foot, the hand, the cubit, the finger.
finger.
I
think
don't
that's
think
all
we
we
can
have.
call the rule of thumb.
But the thumb, I'm going to allow the rule of thumb, but we don't yet have how you measure Goliath. He was 6 cubits and a...
Thumb.
Do I see
No thumb.
someone out here? Kim, did I hear? You can call it out if you know. Span, that's right. So Carrie's sister Kim right here in the audience
Our
got
live
that.
studio audience.
Our live studio audience, 6 cubits and a span. 6 cubits and a span. We're going to have to find a prize for you. Maybe you'd like to come to the math dinner, Kim. Think you could come to the math dinner? Maybe where you can decide. If you can't come to the math dinner, call in and tell us, and we'll see that you get some kind of prize for that. That's right, 6 cubits and a span. So do you know how tall that made Goliath? About 9.5 feet tall.
9.5 feet tall. That's a big guy.
9.5 feet tall,
I could
according
take
to
him,
what we
though. I
now
could take
think.
him.
You could take him.
I
Well,
could take
I
him.
kind of believe it. You guys are still winning basketball, I understand.
We are still winning basketball games.
And a couple more, and you'll be going on to the, what is it?
To the Final Four.
Could be the Final Four. So this is the Final Four.
The
This
Final
is big.
Four. It is big,
This is
very big.
big. This is big. This is big. In fact, I was just reading the autobiography story of Bill Bradley.
Bill Bradley, the senator.
From Princeton, the
Yeah.
senator, and that's where he made his name, right? Wasn't it in the Final Four?
In the Final
Is
Four.
that
Well,
the same
in-
division?
In the NBA also.
And but before that, it was in the Final
It
Four.
was.
That's when he got famous, and that was Division III. Is Princeton Division III
No,
also?
Princeton is Division One.
So that
actually.
was Division I Final Four.
And this is
Division
yes.
III Final Four. But I think
Yes.
equally proud, and I wouldn't be surprised to see you go on and be a senator.
Well, maybe. Let's see what our caller has to say about that.
Let's hear the call.
Live on the air. Go ahead.
Hello?
Yes. Who's
Hi,
this?
this is Mr. Cohen.
Okay, Mr. Cohen. Go ahead.
I have a question. I'm a reporter for WCFM at the college,
Okay.
and sometimes when I get on the show and do some investigative reporting, things get very chaotic. So my question for you is, can you explain chaos theory and maybe how this applies to me?
All right, so here's a call from Mr. Cohen at WCFM about what is chaos and how does that lead what happens to on a program. Well, you know, what's interesting, what mathematicians have discovered, Mr. Cohen, and you'll probably be glad to know about this,
I sure will.
is that when things look utterly chaotic, there is still information that mathematics can tell you about that system.
Like what?
Well, there are certain patterns and orders even to chaos. Now, how that would help you on your program, though, let's see, is there anything in chaos that would specifically help Mr. Cohen on his program? Well, I guess one thing you know is that there will be some variety on the program, right? You aren't
Right.
just
Here's
going
an
to
example. Somebody says a word to me, and I don't understand what the heck they're saying, and then all of a sudden I think they said something else, and I respond to a completely different question.
You respond to a completely different question. Well, you know, maybe this is because human beings are used to patterns. You expect what you've seen before. And chaos is the opposite of that. You don't get any simple pattern, and you get new things occurring at different times. The patterns occur at a much deeper level. So I guess what it says to us who are in showbiz and on the air is that we have to live for spontaneity. And when we get the questions, we have to be listening
roll with the punches.
for something new. Roll with the punches to bring in
Okay, I don't punch
metaphor.
anybody.
Oh, well,
Right, that's good. Now, have you mentioned us on your show, though, Mr. Cohen? This is an important
you
thing.
sure bet this will be on the show come Thursday.
So when are you on the show, Mr. Cohen?
I'm on Thursday from 12 to 2. I just do a little bit on the show.
Thursdays from 12 to 2, but many of our listeners might like to try to tune in. Where is that on the dial?
That's at 91.9 in your FM dial.
91.9 on the FM dial. Okay, well, thanks very much for calling.
Okay,
And
bye-bye.
we'll see if we can listen in this week. That's right.
Thank you.
A lot of good things. There'll actually be something I wanted to mention coming up on Willinet this week. Jeff Straight's faculty lecture at Williams College on Thursday was really very interesting about how signals are now sent by light beams over wires over huge distances. And anybody who missed that lecture can see it on Willinet. It'll be on Tuesday evening at 6:30 and then repeated on Wednesday at 1 o'clock. So there's an excellent event. And I think all the Willinet shows are now listed in the Berkshire Eagle. Is that right? I think that's right.
I think so.
In the Berkshire Eagle, we may get confirmation from upstairs on that. So there are a lot of good shows on Willinet coming in. This one, though, 6:30, right before Around the Mountain, which comes in at 7:30.
Around the mountain, huh? Should we coming around the mountain?
And we got
that same
some
one?
message there. I don't know if I can read
It's
that.
channel
Can you read
15.
that?
Did you say channel 17? Is that
Channel
what you said?
15. Did I? No, Willinet is channel 15.
Yeah.
That has to be known. Channel 15, that's right, is Willinet.
Okay, and maybe our caller has
You
something
go
to
right
say
ahead,
about
Aaron.
that. Live on the air, go ahead.
Yes, hi. I have an answer to the next to the dinner question.
Okay, what's your name?
My name's Greg.
Okay.
Greg, hi, welcome.
Hi, how are you, Professor Morgan? My answer is footlong.
A furlong, is that what you said?
No, footlong,
A foot long.
like a Subway sandwich.
Oh, a foot long like a Subway sandwich. Now there's a modern
What
one.
kind of Subway
This isn't a
sandwich?
classical one, but I guess that's fair, right? A foot long sandwich. Now it's really the same as foot. It's really the same as foot, but I think he's got us on this technicality.
I thought it was pretty legitimate.
Okay, so I think we'll go with that, Greg. And what kind of a prize would you like? Of course,
Well,
you're a Williams College student, is that right?
Yeah.
So you automatically are invited free every week to our math dinners, but you would be an honored guest if you would like to come this week.
What does it mean if I'm an honored guest? What does that mean?
If you're an honored guest, you can sit at the head table beside me,
Whoa.
and we will introduce you at the dinner, perhaps, which will be dedicated to your honor if you'd like to come.
What?
Or on the other hand, if you like, we will provide a copy of Flatland for you.
Oh,
So that's going to
I
be a
think he hung
tough
up on us.
decision. That's going to be a tough decision. Well, I think this decision was a little tough for him, and his roommates.
He just couldn't make it. He
His
just couldn't
roommates
deal
were
with it.
putting some pressure on him
Yeah.
there. But he'll tell us later. He'll either show up at the dinner or tell us that he'd like us, leave a message and tell us that he'd like us to send him a copy of Flatland, which we'd be happy to do too. So a foot long, I guess that's okay, a foot long.
I like the 6-inch subs. I'm not a big guy. I can't eat a whole foot long.
So you know, when they changed, let's see, a 6 inch is enough, I agree. But for these contests coming up, make sure you're eating well enough, Aaron. This is pretty important. So there are a lot of all the units changed when they made the mile a little longer. You can imagine what they did to
Well, the
to
metric
surveying.
units. The metric units.
They didn't
Okay,
change.
they were the same.
So there were all these other units that were changing. And you know, they then defined a metric foot. They then defined a metric foot. You know, I can hardly, a survey foot, which was a little longer, and that stayed the old length, the survey foot. I was distracted, audience, with the sad news that MathChat has come to an end for this week. So we're looking forward to next week's show and next week's MathChat.